Good morning, friends. Myself, Professor S.R. Zagne, Assistant Professor of Agronomy at Sadhguru College of Agriculture, Mirasgaon. Today, I am going to discuss the new chapter, that is the crop discrimination and the yield monitoring. So, this is the chapter number 3 in the course of geoinformatics and nanotechnology and the precision farming. So today we will going to discuss the new concept, that is the crop discrimination and the yield monitoring. So let us start for the topic. Firstly, we will understand what is the crop discrimination. This crop discrimination is also known as the crop differentiation or the crop classification. So the crop discrimination is a necessary step for most agricultural monitoring systems. Then the crop discrimination, it is an usually considered important step for the development and the management of the crop monitoring systems. Since the remote sensing technology which is used for the crop discrimination, both the theory and the technological tools have been in constant development. This has to lead to a remarkable increase in the range of applications and the scope of crop discrimination technique. That means this remote sensing technology, which is an important technique which is used for the crop discrimination. The crop discrimination types using the remote sensing techniques, which are based on the characterization and understanding of the electromagnetic behavior of the target. That means the crop classification or the crop discrimination, which is based on two things. First one is the understanding the electromagnetic behavior of the target. So this is the basic thing, and on which basic thing the crop discrimination or the crop classification is totally depends. Then this behavior depends on the wavelength at which the crop observation is performed. Due to this, the remote sensors for the earth observations are designed to operate at wavelength in which the response of each target, that means the crop type, that is characterized and known, that facilitate on this way to target identification in the scene. So after that, it is important to note that the electromagnetic response of the different parts of the crop cover that not only depend on the wavelength used for the observation, but it is also shows the variations depending on the season, then angle of incidence of the sensor, then crops feature, illumination intensity, weather phenomenon, and the topography among other external factor. That means the electromagnetic response of the various parts of the crop cover, that is doesn't only depend on the wavelength which is used for the observation, but it is also depend on the several factor, that is the season, then angle of incidence of the sensor, crop feature, illumination intensity, weather phenomenon, and the topography. These are the some external factors also responsible for that. Recently, the GIS and the remote sensing technology has come up with a capable role in the agricultural research, predominantly in crop yield prediction, in addition to the crop suitability studies as well as the site-specific resource allocation. Then, the role of geoinformatics to discriminate the different crops at a various levels of the classification, monitoring the crop growth as well as the prediction of the crop yield. So this is about in short the concept of the crop discrimination and which factors on which the crop discrimination it is depend, that is in short we have discussed here. Then we have to discuss about the next important point in this lecture, that is what are the various techniques which are used for the crop classification, crop discrimination, or the crop differentiation. In that, first important technology which is used, that is the remote sensing. So as we know that about the concept of the remote sensing is an efficient technology and the worthy source of the earth surface information. It can capture the images of the reasonably large area on the earth surface. That means the concept of remote sensing is that we can obtain the information about any location without the physical contact. That means we can obtain the information from the long distances by using the technique of the remote sensing. Then, due to the advancement in the sensor technologies, there is the availability of the high spatial as well as the spectral resolutions imageries as and also the non-imaging spectroradiometers, which are also used as a advanced technology in the remote sensing. Then with the use of this imaging and the non-imaging data, we can easily characterize the different species. Then the different crop that shows the distinct phenological characteristic, that means the growth stages, that is the plant life cycle events and the timings according to their nature of germination, tillering, flowering, then boll formation in case of the cotton crop, and the ripening. That means these are the various phenological characteristic of the plant, and the every plant or the every crop which having the different phenological stages or the growth stages. Even for the same crop or the growing season, the duration and the magnitude of each phenological stage can differ between the varieties, which introduce the data variability for the crop type discrimination. Then the agricultural crops are significantly better characterized, classified, then model and mapped by using the hyperspectral data. Then the second important technology or the techniques which is used in the crop classification, that is the feature extraction. Then what is the feature extraction? So this feature extraction is the process of defining the image characteristics or the features which effectively provides the meaningful information for the image interpretation or the classification, that is called as a feature extraction. Then there are some goals of the feature extraction. In that, first goal is that the effectiveness and the efficiency in classification. Second one, that is the avoiding the redundancy, that means the extra space which is required for the data. Then third goal, that is the identification of the useful spatial as well as the spectral features. And last one, that is the maximizing the pattern of the crop discrimination. These are the some goals of the feature extraction that is considered as an important for the classification of the crop or the differentiation of the crops. Then for the crop discrimination, the spatial features are very useful. The crops are planted in rows, either multiple or the single rows as per the crop type that is used to maximize the yield of the crop. Then different spatial arrangement of the crops that gives the better spatial information, but it requires the high spatial resolution images. That means whatever the spatial arrangement of the crop that will provide the spatial information, but for providing this spatial information that requires the high spatial resolution images. Then in spatial image classification, the spatial image elements are combined with the spectral properties in the crop classification decision. Then the next important point, that is the role of texture in the classification. So firstly we will discuss about the what is the texture or the concept of the texture. So the texture means the information in the spatial, that is the space arrangement of the colors or the intensity of the images, that is called as a texture. That means the every image that consists of the texture, and that texture means the information in the spatial arrangement of the colors or the intensity of the images. In general, it is possible to distinguish between the regular textures manifested by the man-made object from the irregular manner that natural object exhibit a texture. Hence, the texture characteristics or the classification can be used for discrimination of the crop or the classification of the crop. For crop classification or the crop discrimination, the remotely sensed data, then conventional texture analysis, and the gray level co-occurrence matrix, that is the GLCM methods, are also used. Then we will discuss here the next important point, that is the gray level co-occurrence matrix method, that is also called as a GLCM method. So in this GLCM method, describing the gray value relationship, that means the gray level co-occurrence matrix method, that basically describe the gray value relationship in the images. Then this GLCM is a statistical method which is used for examining the texture in the images. Then the GLCM can be viewed as a two-dimensional histogram, that is we call as a rectangle, of the frequency with which the pairs of the gray level pixels or the images occur in a given spatial relationship. Then this GLCM method is a way of extracting the texture features. The image composed of the pixel each with an intensity. The GLCM is a tabulation of how often different combinations of the gray level co-occur in an image or image sections. Then next important technique which is used for the classification of the crop, that is the local binary pattern, that is called as a LBP. So this LBP, that stands for the local binary pattern. This LBP is a powerful feature for texture classification. Then the local binary pattern or the LBP is an effective texture which thresholds the neighboring pixel, that means the smallest unit of image descriptor for the images, which is based on the value of the current pixel. Then the local binary pattern or the LBP is a simple yet very efficient texture operator which labels the pixel of an image by thresholding the neighborhood of each pixel and consider the result as a binary number. Then the spectral features for the crop classification. Then what are the various spectral features which are used in the crop classification? In that, the spectral characteristic of the green vegetation which have a very noticeable features. The visible portion of the spectrum are determined by the pigment which are contained in the plant. Then the chlorophyll that absorbs strongly in the blue, that means 0.4 to 0.4 nanometer, and the red which is absorbed in the 0.68 nanometer region, which are known as the chlorophyll absorption bands. So basically the red region and the blue region which is called as a chlorophyll absorption bands. Then chlorophyll is the primary photosynthetic pigment in the green plant. The spectral reflectance signature has a dramatic increase in the reflection for the healthy vegetation at around 0.7 nanometer. In the near infrared, between 0.7 nanometer and 1.3 nanometer, a plant leaf will naturally reflect between 40 and 60%, and the rest is transmitted with only about 5% is being absorbed. Then the three strong water absorption bands are noted at around 1.4, 1.9 and 2.7 nanometer, that is used for the plant water estimation. That means there are three strong water absorption bands are there. These are 1.4, 1.9 and 2.7 nanometer. Basically these three bands are called as a plant water estimation bands. Then next important point, that is the selection of the band or the band selection. So band selection is one of the important step in the hyperspectral remote sensing. There are two types of the spectral bands are there. First one is the multispectral band which having the 3 to 10 number of the band, and second one, that is the hyperspectral band which having the number of band that ranges from 100 to 1000 band. There are two conceptually different approaches of the band selection, like the unsupervised and the supervised data. So these are the two types of the data which is important for the selection of the band. Then due to the availability of hundreds of the spectral band, there may be the same values in the several band, which increases the data redundancy. So that means the additional space which is required for the data, so that can be avoided. To avoid the data redundancy and get the distinct feature from the available hundreds of bands, we have to choose the specific bands by studying the reflectance behavior of the crops. Then next one, that is the narrowband vegetation indices. So firstly we will discuss about the spectral indices. In that process, we have to assume that the combined interaction between a small number of wavelength is adequate to describe the biochemical or the biophysical interaction between the light and the matter. Then after that, what is a hyperspectral system? So the hyperspectral system is the ability to create the new indices that integrate the wavelength not sampled by any broadband system and to quantify the absorption bands that are specific to important biochemical and the biophysical quantities of the vegetation. That means the hyperspectral system. Then the vegetation properties which are measured with the hyperspectral vegetation indices, and this having the three main categories or the types of the hyperspectral vegetation indices. In that first one, that is the structural properties. In that structural properties, which includes the green leaf biomass, then leaf area index, then fraction absorbed photosynthetically active radiation, that means the FPAR, that is the fraction absorption photosynthetically active radiation. Then second one is the biochemical properties. This biochemical properties that includes the water, pigment, then carotenoid, then amethocyanins, then other nitrogen rich compounds like the protein and plant structural material like the lignin and the cellulose. Then third one, that is the biophysical and the stress indices. It measures the delicate changes due to the stress induced change in the state of xanthophyll, changes in the chlorophyll content, change in the soil moisture. Then next one, that is the narrowband vegetation indices. So the narrowband vegetation indices can be used as a potential variables for the crop type discrimination. Then the best vegetation indices of different category to discriminate the crop type, which are greenness, then leaf pigment indices, chlorophyll red edge indices, light use efficiency indices, and the leaf water indices. These are the various narrowband vegetation indices which are used. That is an important category of the hyperspectral vegetation indices. Then the next important point, that is the importance of the hyperspectral remote sensing. So this hyperspectral remote sensing is an advanced tool that provides the high spatial as well as the spectral resolution data from a distance with the aim of providing the near laboratory quality radiance for each picture element, that is from a longer distances. Then the recent advances in remote sensing and geographic information has led the way for the development of the hyperspectral sensors. Then the hyperspectral remote sensing is also known as the imaging spectroscopy that study the visible light. It is a relatively new technology that is currently being investigated by the researchers, then scientists with regard to the detection and the identification of the minerals, then terrestrial vegetation and man-made materials as well as the background. Then the hyperspectral remote sensing that combines the imaging and the spectroscopy in a single system, which often includes the large data set and that require the new processing methods. Then the hyperspectral data sets are generally composed of about 100 to 200 spectral bands of relatively narrow bandwidth, whereas the multispectral data sets are usually composed of about 5 to 10 bands of the relatively large bandwidths, that ranges between 70 to 400 nanometer. And the hyperspectral remote sensing, that means the HRS, and the imaging spectroscopy, that is the IS, these are the two technologies that can provide the detailed spectral information from every pixel in an image. Then next important concept, that is the yield monitoring and the mapping. So in that, firstly, yield monitoring, that is the estimation of the crop yield well before the harvest at regional and the national scale, which is imperative for the planning at a micro level and predominantly the demand for the crop insurance. Then, the crop yield estimation plays the significant role in the economy development. Currently, it is being done by extensive field survey and the crop experimentation. Then yield monitoring equipment, which was introduced in early 1990s, and it is increasingly considered a conventional practice in the modern agriculture. Then there are some approaches and the various technologies which is used for the yield monitoring, which is called as a crop inventory. In that, first one is the aerial photography. There are two distinct aspects of the yield estimation. In that, first one, a forecast of yield, which is based on the characteristic of the plant or the crop, and the second one is the estimates of the crop yield, which is based on the actual weight of the harvest crop. Then after the World War II, the various researchers that used the emerged concept of the aerial photography for the optimized use of the resources for the agricultural and the crop inventory. Then the black and white photography has been used for the crop identification, primarily based on the ground appearance photographs of the selected fields and the growing the seasons of the crop. Then second important approach and the technology which is used for the yield monitoring, that is the multispectral scanner. So the multispectral scanner having the 0.3 to 14 nanometer or the more bands. This MSS or the multispectral scanner have the certain advantages and disadvantages compared to the photography. Then ability to differentiate feed from the other agricultural crops using the multispectral scanner data in a computer format. An important consideration in the task of species identification is the any stage of the growth of the crop. So these are the two important approaches which is used for the crop monitoring. Then the third approach, that is the radar, that means the radio detection and the ranging. The radar sensors are able to capture the plant structure and the soil moisture content. The radar sensors can contribute to measuring the crop condition at different phenological stages that are useful to estimation of the crop yields. Then there are some airborne or the spaceborne radars are used for the crop identification. Then radar studies have concentrated on the seasonal yield data estimation of the crops. Then fourth approach, that is the satellite data or the remote sensing data. The remote sensing data has been proved effective in predicting the crop yield and provide the reprehensive and the spatially information of the crop yield estimation. Then in India, remarkable in the remote sensing activities has started with the launch of IRS, that means the Indian remote sensing satellite, in the year 1988. The India launched a variety of satellites such as the ResourceSat, Cartosat and the OceanSat. So these are the four important approaches or the techniques which are used in the yield monitoring. Then the next important point in this lecture, that is the potential application of the yield map and the mapping. So yield map that represent the output of a crop production. On one hand, this information can be used to investigate the existence of the spatially variable yield limiting factors. Then next one, that is, on the other hand, the yield history can be used to define the spatially variable yield goals that may allow the varying input according to the expected field productivity. The next important application, that is the yield maps are one of the most valuable sources of the spatial data which is used for the precision agriculture. And the last application, that is in developing this map, it is essential to identify the points or the location where get the higher and the lower crop yield. So these are the some important potential applications of the yield map or the yield mapping. In this way we have completed this lecture number 3. As in this lecture we have discussed in detail about the crop classification and the yield monitoring. Thank you.